is the other end of the spectrum, okay? We just heard about the vision, okay? Now I'm the number cruncher, okay? I gotta look at all the data and figure out what the trends are, what the tendencies are, what uses are supported, and why do we care, okay? My function in DEQ, I'm in the Water Quality Standards section. I'm responsible for numeric water quality standards. So the document you may know as DEQ 7 is a document I have to review every year and figure out what needs to be added or changed, etc. to keep it up to date. That's basically a list of 285 compounds for which we've set specific limits. And we're going to talk about what constitutes a water standard. But what we're trying to do right now is look at a tremendous amount of data that's been collected on Silver Bell Creek. Everybody and his brother, at least, have gathered some data, and it's in different databases, trying to consolidate that data to get a clear picture, put everything, so to speak, in a common table so that you can mess with it in a computer. It's proven to be a real challenge. Okay, let's talk about what are water quality standards. There's 4 portions to a water quality standard. Designated uses of the water body, things like drinking water, recreation, quality of life, agriculture, industry use. Those are designated uses. Second aspect of the water standard is the water quality criteria. Those are numeric pollutant concentrations, narrative requirements. In this paper outlined in DEQ 7. Then we have the third component is an anti-degradation policy to maintain and protect existing uses and high-quality waters. And the fourth component is the general policies addressing implementation issues like low flows, variances, mixing zones, anything that you use from the body of water or any criteria from the body of water that are used to set the limits in which measurements must be made. Okay, what's a UAA? It stands for Use Attainability Analysis. It's a structured scientific investigation of the water body to determine if its existing uses, to determine its existing uses and its potential to fulfill other uses. And that's extremely important in this case. It's easy to talk about, well, relatively easy, to talk about what is Silver Bell Creek used for, what uses does it fulfill today. But what's its potential? That means we have to look at the history of this creek. What was it 100 years ago? What was it 10 years ago? What was it 30 years ago? How has it changed over that time? So trend analysis in the data is extremely critical to analyzing what's going on in use attainability analysis. Typically, a use attainability analysis is triggered by events that suggest the water body is misclassified, okay? And most UAAs downgrade the uses of a water body. In other words, basically you're going to have to convince the EPA that you have solid justification for the removal of the use of a given water body. Okay? Now, in the case of Silver Bell specifically, it is what's called an I-class stream. We're going to talk about classification because you can't understand what I'm doing if you don't know what the classification system is and what it designates. Okay? The UAA process, depending on what you're trying to do, can be extremely detailed and very complex. It involves a detailed review of both historical information, which is older than 10 years, as EPA defined it, and the current data, which is the past 10 years. And you have to qualify all the scientific data. Now, what does that mean, qualify? Well, you have to say, did the person who collected the sample do it properly? Was the sample transferred appropriately to the lab? Did the lab do the right analysis with the right EPA-approved technique? Was quality assurance carried out during the lab conduction of that sample? Who ran the sample? We have to know all of that for every single sample, okay, in order to qualify as being appropriate data to include in our analysis. And then we also have to look at planning associated with changes to the water body. Now, what Clark's Fork Coalition did with this is in planning documents, what they'd like to see happen to that water body. And so we temper the scientific information we already have collected with the socioeconomic impact of changes to that water body. If I increase the level of protection of the water body so that it meets every possible use, what's the socioeconomic impact of doing so? I bring 10,000 more fishermen into the Deer Lodge Valley, it's got to have some kind of impact. So those are the kinds of issues we may look at in the UAA. Now, Silverbow Creek specifically, trend analysis of the metals in Silverbow Creek has shown significant improvement over the last 7 to 10 years. In addition, excellent planning for further improvements over the next 10 years has been put forth by the EPA, BNRC, Clark Fork Coalition, and other public groups. These are, when we say plans, maybe they're not funded, but they're at least people thinking about it. Here's a proposal. Here's how much we think it would cost. Here's what the goal is. So those types of documents are valuable in a UAA. And the DEQ feels that significant progress has been made to date that justifies the detailed analysis necessary to consider reclassification. Now, reclassification, what are we talking about? Okay. Most UAAs, you have some water body and it's on the left end of nowhere. You don't really know very much about it. And so you go, oh gosh, we better plan a 2-year study plan. And let's go out and collect data, do it at least for 2 years so that we know what's going on. That's not my problem. I got data up to the ceiling, okay? I got data coming out my ears, okay? In the last 10 years, 8 state and federal agencies have collected over 100,000 samples. Now, when I say a sample, analysis for metals, analysis for fish populations, riparian evaluation, sedimentation evaluation, every single type of sample. There is nothing, as far as I can tell, that hasn't been sampled on Silverbow Creek. And so, a huge part of our issue, if you will, in considering reclassification is filtering that to get to the data that we actually need to make an informed decision. If you just say, I got 100,000 data points and I'm hoping I figure out what's going on without asking the right question up front, you will get lost and you can't see the forest through the trees, sort of an approach. So a lot of what we've been doing to date has been just trying to define the problem. What is it that we need to critically separate one classification from another? Where are we trying to go with this in terms of what questions we have to ask? Okay, one of the biggies is identification and communication with interested parties, which is required of a UAA. And this is just a partial list. If I've left somebody off, I'm sorry. I ran out of space. It's small print. And Clark's Fork Watershed Education Program made it on there twice, so it was short. These that are in green are organizations that have submitted data that has qualified through the data qualification process. We have individuals within DEQ whose sole job is quality assurance on data input. Now, there are lots of different databases, and major organizations like USGS use a completely different database than EPA. So you can make them talk to one another, but it ain't easy. So, how do you get the data sets to match up? Simple questions like, how did you do the sulfur determination for sulfur? There's different procedures. How about nitrogen? Did you make your nitrogen determination as nitrate plus nitrite, or was it as inorganic nitrogen? How did you qualify it? Except it just goes on and on. So with this many agencies submitting data, and It's not that we're trying to exclude anybody else's data sets. It's just that those are the ones we've waded through. If you got more, bring it on. We'll figure it out. Okay? We have a full-time data analyst whose job is to create data, I guess I'll call them macros, that transfer data out of your data set into a more standardized internet or national data set, so it can be included in the newer versions of STORET or EQUIS as databases, which are fancy databases that are very powerful as long as you get them in properly. Garbage in, garbage out. Boy, is that true of all this. Okay, Silverboat Creek, just some numbers to throw at you. I'm going to describe the segments. We talk about segments on the creek. The Silverboat segment is 29.2 miles from Blacktail Creek. It's not too far short of a mile here. It's, well, it does, but eventually. Okay, it's currently impaired for aluminum, arsenic, copper, iron, lead, manganese, nitrates, physical substrate habitat alterations, sedimentations, silver, and zinc. So, oof. And the I classification it was assigned was actually assigned in December of 1972. Okay, and the full 303D assessment for the impairment list was done in 2006. There's been lots of work done prior to 2006, but there's a formal process, the 303D list process, which was put on, focused on Silverboat Creek in 2006. Now, the I class, what does I stand for? Indeterminate. There's only 3 rivers in the whole state that have ever had that classification. Right? Sort of like a dubious distinction in the word military. It means that the situation was so complicated in 1972 they couldn't figure out what class it should be. Okay. Here is a map showing the run of river that is being considered. That is the I-class segment right here. Okay? And it's got a number assignment. It's specific to these specific GPS coordinates. We have coordinates that describe all of the segments all the way through to Missoula for the entire upper part. But this is just this I-class segment.
Excuse me, so does that start at Montana Street or does it go up Blacktail?
It starts at Montana Street or just a little before that. Just actually a little bit on the other side.
No, okay, at the confluence.
Yeah. Okay, this is probably a painfully familiar picture for those in here. And if you look really close, you see a whole bunch of little tiny numbers here. And this is obviously the LAO segment down here. All right, this is Montana right here. Yep. Do native verification. I was on the ground actually. Now, if you look at this, let's just take a look at this little section right here. Okay, here's SS05, SS05.6, 5.7, 5.9, 5A, 5B. Okay, this is, Joe, what kind of distance would you say that is?
Quarter of a mile.
Quarter of a mile. Okay, so we've got 1, 2, 3, 4, 5, 6, 7 data points in a quarter of a mile. Okay, why? That's the kind of question we have to ask. Why did 7 different locations in a quarter mile segment become selected? They could all be valid. There could be perfectly good reasons for having 7 different locations. Okay? But maybe not. Okay? How do I group this data? Do I consider 5.9, 5.7, 5.6? I mean, the distance between 5.6 and 5.7 is about what? 10 feet? 15 feet?
No, it's at least 30 feet.
30 feet? Okay. I'll give you 30 feet. So when we get data like that, we have to ask the question, should it be grouped together? Should it be kept independent? If so, why? Okay. So just on this small, between here and here, we have, I think, 16 data points, 17 data points. Okay. And that's just in Butte, like the town of Butte. get outside, there's a total of 29. It's something like that. And that's, I guess those are what I'll call the consolidated values. Then there's all the stuff that people like Montana Tech did, which aren't on here. USGS, some of them are on here, some of them aren't, etc. So very complicated.